In this class, we are going to study about the memories, different types of memories available. Okay, so what are the advantages and disadvantages of memories? So coming to the definition of memory, so memory is nothing but a collection of storage cells, and it is capable of storing information in binary format. So binary in the sense it can store the information in the form of zeros and ones. So coming to the basic definition of memory, so memory unit is a collection of storage cells in the sense flip-flops, together with associated circuits needed to transfer the information in and out of the device. So here it is a memory unit because it is capable of storing large amount of data, and it is a collection of storage cells. Okay, so those can be flip-flops. Okay, so which are constructed using gates, or sometimes these storage cells can be MOSFETs. Okay, that means transistors. So together with associated circuits. So with associated circuits in the sense, since memory is capable of storing much information in it, so sometimes we need to select which type of word, okay, so we need, or which type of word is to be written into the memory. So to select such type of things, so we need associated circuits. Okay, so that is why, so we need some some devices like decoders to select the address. Okay, so from which we need to read the information, or from to which we need to write the information. So that is why to transfer the information in and out of the device, so we need some associated circuits. So memory cells can be accessed for information transfer to and from any desired random location, and hence the name random access memory. So here we have two types of memories. So those are RAM and ROM. Okay, so RAM in the sense random access memory. So here how we are going to get the data, okay, or can write the data. So here random access memory allows us to perform two operations, that is read and write operation. And whereas, since why it is called random access memory, because these memory cells, okay, can be accessed for information transfer to and from any desired random location. So if you select certain type of location which is at any point in the memory unit, okay, so here we are able to do that. So that is why it is known as random access memory. And a memory unit stores the binary information in groups of bits called words. So here bits in the sense that is 0 or 1. So here memory unit can store the information in the form of words. So words in the sense it is group of 16 bits. So that means each word contains 2 bytes in them. Okay, so 1 byte is 8 bits of data. Okay, so here random access memory. Okay, see, it is possible to access any type of location. Okay, so based on its capacity. So that is the reason it is known as random access memory. Whereas we have one more memory unit which is called ROM. Okay, so ROM allows us only read operation. Okay, it is not possible to write into that. And a word in memory is an entity of bits that move in and out of the storage as a unit. So here in the memory, in the random access memory, so we access the information in terms of words. Okay, so the input can be given in terms of words through an input lines. Okay, and we get the information out of the memory in the form of words by using end data output lines. So here a memory word is a group of ones and zeros, okay, which is nothing but the binary information, and may represent a number. Okay, so an instruction, one or more alphanumeric characters, or any other binary coded information. Okay, so here the memory is able to hold any type of these things. Okay, so it can store the numbers, it can store the instructions. Okay, that means controls. Okay, so it is able to hold alphanumeric characters, okay, which can be used, okay, so in the computer, okay. So any other binary coded information, any type of information can be stored in memory in the form of words, which is nothing but the group of ones and zeros. So a group of 8 bits is called a byte, and the capacity of a memory unit is usually stated as the total number of bytes that it can store. Okay, so the capacity of memory can be given. Okay, so using the number of bytes it can store. Okay, so if it stores, okay, 1024 bytes in it, so its capacity is 1024 bytes. Okay, so and based on the number of bits stored, okay, so that is if it is able to store 1024 number of locations, okay, in the form of words, in the sense 16 bits. So that is why each memory input data or output data, okay, so contains 16 bits in it. So for example, if you look at this diagram, we will get to know this easily. So this is the content of 1024 by 16 memory. That means it is possible to hold 1024 locations. Okay, so it is able to hold 1024 addresses in it, and each of information, okay, present in that any location of out of 1024 is of 16 bits. So here if you see the memory address, okay, so in terms of binary and decimal. So the address can hold is 1024, whereas each word which is present in the memory content. So if you look at it, so it is of length 16 bits. Okay, so that is why the storage of this memory, random access memory, is given like the number of addresses it can hold and what are the number of bits available in each word. And here is a block diagram of random access memory. So here the memory unit is able to store 2 power k words in it, and each word contains n bits in it. Okay, so that is why we have n data input lines, okay, and we have n data output lines. So whatever we are going to write, okay, is given on the n data input lines, and whatever data we are wishing to get out of the memory, okay, so can be visible at n data output lines, and from which location we need to get that data, so is specified by the k address lines. Okay, k number of address lines are necessary to store the information or to get the information from that particular location. So here read and write are two control signals. So to specify whether the information can be read, okay, from the memory or can be written into the memory. So then the n data input lines provide the information to be stored in memory, and the n data output lines supply the information coming out of memory. So as we said, okay, as I discussed earlier, so n data input lines provide the information to be stored into the memory. So that location is specified by k address, okay, k number of address lines. Okay, so if we want to write the information at particular address, for example at 16 address, so the k address, okay, the k number of address lines specify the location of 16 and what amount of the data, okay, should be written into the memory. Okay, for example I want to store 15 value into the memory. Okay, so then that 15 is specified in terms of n input lines. Okay, so here the k address line specify the particular word chosen among the many available. Since we have many available addresses in them, so this k address specifies only that particular address. Okay, so where we need to write or we need to read from that location. So the two control inputs specify the direction of transport desired. Okay, so those control lines nothing but read and write, okay, control inputs. So if we enable read, okay, so we can get the data from the memory. So if we enable the write signal, okay, so then we are going to write the information into the memory. So the write input causes binary data to be transferred into the memory, okay, so whereas the read input causes the binary data to be transferred out of the memory. So as discussed earlier, this is how we are going to deal with the memory. So this is the memory unit which is capable of holding 1024 locations, and each value stored in that location is of 16-bit size. Okay, so here the binary address, okay, and whereas the decimal value of the binary value is given. Okay, so at each location particular information is stored in the memory. So coming to the write and read operations, how we are going to perform write operation and read operation. So for example, coming to the write operation. So transfer the binary address of the desired word to the address lines. Okay. So at which location we need to write the word. So it should be specified by using k number of binary address lines. And after that, we have to transfer the data bits that must be stored in the memory to the data input lines. So through the input lines available in the block diagram here. Okay. So here n data input lines. So we have n data input lines. So on these lines we have to specify what is the amount of information. Okay. So to be written at a particular address. And then we have to enable the write input. So the writing operation will be done then. So coming to the read operation. So if we want to read the information, okay, from the memory. So what we should do now? So similarly, first we have to specify the binary address. Okay. So in the form of okay, so by using k address lines. Okay. So what from which location we need to access the information, okay, should be specified using address lines, and then we have to activate the read input. So then on the n data output lines, so the read information can be specified for us for the reading. Okay, so this is how the read operation is done. Okay, so this is how we are going to represent the read or write operation. So control inputs to memory chip. So when memory is enabled only, it is possible to write or read. So otherwise it's not possible. So memory enable, if memory enable is 0, so read or write or operation is not done. Okay. So memory operation is nothing. So whenever memory is enabled, okay, so then if read, okay, so if read is 0, that means write is 0. If read is 0, write is 1. Okay. So then we are able to write the word, okay, to a selected address. Okay. So the selected word can be written into the memory. So whenever read or write is 0. And when memory is enabled and read or write is 1. Okay. Since here read is 1, so we can read the information stored at a particular address. Okay. So the selected word can be accessed at the data lines, data output lines. So whenever read is 1, read or write is 1. Coming to the types of RAM, okay. So till now we have discussed what is RAM, okay, how the data is stored in RAM. So coming to the types of RAM, okay, we have basically two types of random access memory. So those are dynamic RAM and static RAM. Okay. So dynamic, what is dynamic RAM, or what is the advantage of dynamic RAM, or what is static RAM, and what is the advantage of static RAM over dynamic RAM, let us see. So dynamic RAM is nothing but it loses its stored information in a very short time. Okay. So even when the power supply is on, so though the power supply is on, okay, so dynamic RAM easily loses its information. Okay. So whereas coming to the advantages of dynamic RAM, so these are cheaper and its cost is very low. Okay, this is only the advantage of dynamic RAM. Next, coming to the static RAM. Unlike dynamic RAM, it retains its stored information as long as the power supply is on. So till the power supply is available to the memory, okay, so it is able to hold the information stored in it. Okay, so this is the advantage of the static RAM over dynamic RAM. Okay, so but the disadvantage of static RAM is, so these are costlier since they can retain its information till the power supply is on. Okay, so those are very costlier since the power supply is need to be supplied. Okay, so to retain the information for static RAM, okay, so it consumes more power. So these are the disadvantages of static RAM. And coming to the advantage, okay, so they have higher speed than DRAMs. Okay, so since the DRAM can lose its information within short period of time. Okay, so unlike dynamic RAMs, these have higher speed. Okay, they can store the information up to a long time. Next, coming to the read-only memory or ROM. Since the name specifies us, only we can read the information from the memory, and it is not possible to write any information into the memory. And the one more advantage of read-only memory is it is non-volatile memory. So here in the RAM, so when we discussed about the types of RAM, okay, so the RAM is volatile. Why? Because it loses its information as soon as the power is off. So when the power is not available, RAM loses all of its data. So that is why RAM is volatile memory. So whereas ROM is non-volatile memory because it can retain its information. So though power supply goes off, okay. So RAM is in the sense it's read-only memory. Only it is possible to read the information from the memory, and it is not possible for the user, okay, to program it. So it is non-volatile memory. That is, the information can be stored in it, okay. So and not lost even the power supply goes off. It is used for the permanent storage of information. So many of the programs are stored in it, okay, and it is permanent storage information, okay. So and it is permanent storage of information. So information cannot be written into ROM by by the users or programmers, and it is not possible for the user or even the programmer who is using it, okay. So it is not possible to be written into the ROM. Okay, in other words, the contents of ROMs are decided by the manufacturers. So only the manufacturers who are going to manufacture the memory units are responsible to write the content into the ROM. So the users are unable to write any kind of information into the ROM. So that is why it is only read-only memory. So this is the basic structure of ROM. Okay. See here, since the ROM is read-only memory, so it is possible to access only information from the memory. Okay. So it is not possible to write any of the information. That is why here none of the write operation is stored. Okay, is shown. Whereas the ROM is able to hold 2 power n by n. Okay, so this is the capacity of ROM. Okay, so here 2 power n in the sense it is possible to select 2 power n values. Okay, so from ROM. Okay, so by using the address lines. So that is why decoding is necessary. For that, decoder has been used in the structure of ROM. So here, for selecting 2 power n values, okay, from the ROM, okay, so at the M output line, so we require decoder to select 2 power n or to access 2 power n address locations. So here we have a decoder of n by 2 power n, okay, size. So the input lines are n input lines, okay. So this decoder contains n input lines, okay. So whereas it is able to provide us 2 power n output lines. So which are used to select any of locations from 2 power n locations. Okay. So and at the output line m output word is accessed. So it consists of n input lines and n input lines. So each bit combination of the input variables is called an address. So as we discussed earlier, okay. So each input, okay. So at the memory is nothing but it specifies certain address. So each bit combination that comes out of the output lines is called a word. So similar to the RAM, so ROM also contains the words in it. Okay, the information can be stored in it in the form of word. That means contains 16 bits of information in it. That is nothing but 2 bytes. So the number of bits per word is equal to the number of output lines. Okay, so that is why m output lines we have shown here. Okay, so here that m output lines store the information of in the form of a word, that means 16 bits. And an address is essentially a binary number that denotes one of the minterms of n variables. Since we have used here decoder, so here 2 power n addresses are available. So each address is nothing but the minterm of n variables. Minimum term of n variables. So the total number of distinct addresses possible with n input variables is 2 power n. Because the decoder is able to provide the 2 power n locations, so which can act as address, okay, to select particular address for the memory unit. So an output word can be selected by a unique address, and since there are 2 power n distinct addresses in a ROM, so there are 2 power n distinct words that are said to be stored in the unit. Since we have 2 power n distinct addresses, okay, so n can be any input value based on the capacity of ROM. Okay, so 2 power n distinct words are stored into the ROM. Okay, so and whenever we require, so particular address, okay, selected address has been given to the ROM and m outputs. Okay, so the value which is specified at the specific location, okay, can be read out at the m output lines. Next, coming to the types of ROM. Okay, since ROM is not allowing the user, okay, so to program, so here we have some flexibility when we use the other types of the ROMs. Okay, so here there are basically 5 types of ROMs: PROM, EPROM, EEPROM. Okay, so and then flash memory. Okay, so these are different types of ROMs. Okay, so unlike the first basic structure. Okay, so here the first type of ROM, okay, is nothing but PROM, which is nothing but programmable ROM. So it is programmable ROM. That means it is possible to write the content by the user. Okay, so its contents are decided by the user. The user can store permanent programs, data, etc. in a PROM. So here, unlike the basic structure, it is possible to write the contents by the user into the ROM. So such type of ROM which allows the user, okay, to program the ROM is nothing but programmable ROM. But here we have to store permanent programs in it. So once we store the information, it is not possible to erase it again. So that is why we have to select a particular, okay, so what kind of, we have to be very specific while writing any information into the PROM. Next, coming to the another ROM which is nothing but EPROM, okay, erasable PROM, erasable programmable ROM. So since PROM is not allowing us to erase any data, so we have another choice which is nothing but EPROM. So here it is possible to erase the data from PROM. Okay, so that is why it is known as erasable PROM. So the stored data in EPROMs can be erased by exposing it to ultraviolet light for about 20 minutes. So if we expose this EPROM to the ultraviolet light for 20 minutes of time, it is possible to delete the data present in the EPROM. But it is not that easy. Okay, because EPROMs has to be removed from the computer, and then it has to be exposed to the ultraviolet light. So that is why we should be very careful while removing this EPROM from the computer. And coming to the another advantage, okay, so the entire data is erased and not selected portions by the user. Okay, EPROMs are cheap and reliable. So here if we want to delete the data from EPROM, so the entire data should be deleted, and it is not possible to select a portion of data. Okay, so whatever the content we have stored in the EPROM must be erased. Okay, so using UV light. Otherwise, it is not possible to select which type of data should be deleted. Okay, whereas coming to the advantages of EPROMs are, so these are very cheap and reliable. Okay, so since the cost is less, okay, so this is one of the advantages of EPROMs, and reliable because it is easy to use and the data can be erased. Okay, so that is why these are reliable. Coming to the one more flexible ROMs, okay, that is nothing but EEPROM. So here electrically erasable PROM. Okay, previously EROM, okay, EPROM can be removed. We have to remove it from the computer and we have to expose it to UV light. Okay, so that is a bit difficult. So here these are electrically erasable. Okay, the chip can be erased and reprogrammed on the board easily byte by byte. Okay, here no need to remove it from the computer. So it can be kept on the board, motherboard as it is. Okay, and it can be erased by using electricity and can be reprogrammed again. Okay, so unlike EPROM and PROM, so it can be reprogrammed once again. Okay, but here also all the content must be erased and we can reprogram it once again. So it can be erased with a few milliseconds. So unlike EPROM, okay, so here it doesn't take much time. It uses only few milliseconds of time to erase the data. But there is a limit on the number of times the EPROMs can be programmed. Okay, so that is usually around 10,000 times. So usually the reprogramming, okay, so is done only a particular number of times. So if you continuously erase the data and reprogram it, the EPROM, the EEPROM will not work. So it has certain limit. Okay, that limit should be around 10,000 times. So if we erase the data more than that, so it is not possible to reprogram it once again. And coming to the more flexible device, okay, memory device, which is nothing but the flash memory. So it is an electrically erasable and programmable permanent type memory. Okay, so here we can erase this any number of times and can be programmed any number of times, and it is act as a permanent type of memory. Okay, so the disadvantage of EEPROM, okay, so where it is possible only to erase and reprogram only particular number of times can be eliminated by using flash memory. So flash memory can be electrically erasable and can be reprogrammable any number of times because it uses one transistor memory, okay, all resulting in high packing density and low power consumption and lower cost and highly reliable. So since flash memory is using transistors to store the information in them, okay, so it uses low power consumption also, okay, and its cost is very low, okay, because it is not, so here we are not going to buy the another type of memory because it can be erased any number of times and can be programmed it once again. Okay, and since transistors we are using here, it requires less cost. Okay, and higher reliability. That means we can erase and we can use it any number of times. So that is why it has high reliability compared to the previous memories. So it is used in all power, okay, storages, okay, and digital cameras, MP3 players, laptops, mobiles. So all this, okay, the memory present in all these types of appliances are nothing but the flash memory, because it has high packing density, because we are using transistors, okay. So any number of transistors can be integrated in this memory, okay. So thousands of transistors can be packed at a small area. So that is why it has high packing density and it consumes low power, okay. So unlike the previous RAM and ROM devices, okay, and these are available at low cost also, because on single IC, on single integrated circuits, thousands and millions of transistors can be manufactured, okay, can be designed, okay. So that is why it has these are very low in cost and high reliability, because we can use it for many number of times. Hope you understand the types of memories. In the next class, okay, in the next lecture, we are going to see what are programmable logic devices. Thank you so much.